Welcome to EasyBTech channel. Myself Ravi Kumar. In this video, I will discuss about the network theorems, that is superposition theorem. First of all, what is the statement of superposition theorem? That is, it states that the response in any element is equal to the sum of the responses by considering only single source, while other sources are eliminated. That is, if other source is voltage source, the voltage source can be eliminated by short circuit. If other source is current source, then the current source can be eliminated by the open circuit. That means you have to find out the response by considering only single source only at a time. Then other sources are eliminated. What is the response? That is our finding value in the given problem. That is, maybe it is current passing through the element, or voltage across the element, or power loss in the element. Any value, what is the finding value in the given problem? That is called the response of the circuit. You can verify the superposition theorem by taking simple example here. Consider the circuit. In this circuit, you have to find out the voltage V across 4 ohms. That is, here in the circuit we have two sources, 6 volts voltage source, 3 amperes current source. That is, you have to find out the response is voltage here in this problem. That voltage you can find out two times. The first time by taking voltage source, the second time by taking current source only. Okay. For that, you have to consider the first case is, that is, for step 1. For step 1 is nothing but you have taken only 6 volt source. 6 volts voltage source is acting alone. That is, you have considered only 6 voltage source. Then other source here in the first step, other source is current source. Then how to eliminate current source? Then current source will be eliminated by open circuit. Then simply again you can draw the at every step, you can draw the equivalent circuit. That is, then you have to eliminate the current source here. How to eliminate current source? By taking simply the current source will be, you can delete by consider open circuit. Then you can mention here delete current source and we have mentioned OC, that is open circuit. Then in open circuit there is no second loop, only the circuit changes into only single loop. Then you have to take in the single loop current is I. Okay, before going to find out the voltage V across 4 ohms, first you can find out current here. Okay, then how to change the circuit after deleting current source? It becomes only single loop value. Then single source and total resistance is 8 plus 4, 12. Hence, what is the current value here? I equal to total voltage by total resistance, that is 6 by 12. Then that value is nothing but here 0.5 amperes. Okay. Then after finding the current value, then we have to find out the voltage here. Okay. This is the first step. Then we can consider the voltage here V1. Then voltage across the 4 ohms is nothing but V1. Okay. Then according to Ohm's law, V equal to I into R. Then V1 equal to 4 into I. Then 4 into 0.5. What is the value here? That value is 2 volts. Okay. This is the first case value. That is, we have find out V1 by taking only single source, voltage source 6 volts. Similarly, second step. What is second step here? We have to consider only current source here. We know What is step 2 here? That is 3 ampere source is acting alone. What is the meaning here? You consider only current source. You can eliminate voltage source. That is second step. Then again you can draw the equivalent circuit from the given circuit. Then how to change the equivalent circuit here? Simply then the voltage source will be eliminated. How to eliminate? Simply that voltage source is nothing but short circuited. Hence we can draw the open circuit. The current source will be short circuit. Then you can mention SC, that is short circuit. Okay, observe here 3 ampere source will be total current value. Then that current will be divided into 3 currents, 2 currents. Okay, at this node. Okay, we have considered the current passing through 8 ohms is I8. The current passing through 4 ohms is I4. By applying current division rule. What is current division rule here? That is apply current division rule here. Why? Because we have two resistance in parallel and total current we know. Hence, here our aim is to find out current passing through 4 ohms. Okay, this is the second case. That's why our finding value taken as V2. The voltage across 4 is taken as V2. Then, before going find out V2, you can find out current passing through 4. Okay, what is current division rule here? That is current passing through branch equal to total current 3 amperes into 4 ohms, opposite value of the 4 ohms. Opposite value is 8 by total resistance 8 plus 4. Then that value of I4 is nothing but here 2 amperes. The current passing through 4 ohms is 2. Then therefore voltage across 4 ohms by taking only current source, that is I4 into 4, that is V equal to IR. Then resistance value for current is 2. Total is 8 volts. Then apply superposition theorem. Therefore, from superposition theorem is the response. What is response here? V, our finding value. The response is equal to the algebraic sum of responses. That is the sum of two responses, V1 plus V2. Then what is the V1 value here? V1 value is 2 volts and V2 value is 8 volts. Then the total value becomes here 10 volts. Okay, this is the total response value by taking only single source at a time. So that is the statement of the superposition theorem. The algebraic sum of the responses caused by taking only single source at a time. Other source will be eliminated. Other source will be eliminated. That is the voltage source is other source. Then that source will be eliminated by considering only current source. If other source is voltage source, it will be short circuited. If other source is current source, it will be open circuited. Yeah? Remember here the two important point is that eliminate the sources. Okay? How to eliminate the sources? Okay, that is the important points in superposition theorem. Okay? Once again, can consider another problem, that is AC circuit problem. In university examinations also, most of the theorem problems are given for AC problems. That is, the circuits are given by considering AC elements. That is the voltage source, current source, or AC, or elements also, or LC elements are considered. Okay, most of the problems are given on RLC element. Okay, to verify the theorems. Consider this circuit here. Here also we have two sources. One voltage source, 20 voltage source, and current source is 5 amperes. Then, but here we have three loops. Already current directions are taken. Okay, that is I1, I2, and I3. Okay, this is the first loop I1, This is second loop, I2. This is third loop, I3. Okay. Then we can verify, find out the current I0. That is, this is the I0. You can find out the current I0 by applying superposition theorem. Okay. Then we can solve the theorem, that is, for the given circuit. What is step 1? That is, first step is, what is first step? Consider only 20 voltage source. 20 voltage source is acting alone. That is, you can eliminate other source. In the circuit, what is other source? Current source. Then again, you can draw the equivalent circuit from the given circuit. Again, you can draw the equivalent circuit here. Then simply then here eliminate current source. Then delete current source. How to delete current source? It will be open circuited. Then there is no third loop. Third loop is completely eliminated. Why? Because current source is open circuited. Then find out here the current I0. Then here simply observe here in this circuit after changes the impedance J10 in series with 8 ohms. Okay? Then what is the impedance here? 8 plus J10. That 8 plus J10 in parallel with minus J2 ohms. After paralleling both elements in series with 4 minus J2 impedance. So that is the total impedance of the circuit after eliminating the current source. That is, you have to find out total impedance Z here. Then 8 plus J10, that is complex number impedance, both are series, then added. That combination is in parallel with J2. The combination in parallel with J2. Then after paralleling both elements, then that combination is in series with 4 minus J2. Okay, you can simply the impedance value, that is series and parallel combination, then you will get the total impedance value is nothing but 4 minus 25 minus J 4 minus 25 ohms. Okay, this is the total impedance value after simplifying series and parallel combinations. Okay, we know total voltage here 20 and we know total impedance also here after calculation. Then find out total current here. Okay, this is first case considering. Then for example we are taking as I naught dash. Okay, therefore the current, the finding value current I naught dash equal to simply V by Z, total voltage by total impedance value. Okay, what is the total voltage here? Total voltage nothing but here 20 at an angle 90 given. You can change into complex number, that is rectangular form, that is J20 by impedance value 4.25 minus J 4.25. Then what is the current value here? Minus 2.353 plus J 2.353, that is amperes. Okay, this is the first case current. Similarly, you can find out second case here. What is the second step? That is step 2. What is second step? Only you can consider 5 ampere source only. Then 5 ampere source is acting alone. Then other source is voltage source. Then how to eliminate other source? You can simply eliminate other source is current source. Then it can be eliminated by taking short circuit. Then again you can draw the equivalent circuit from the given circuit. Okay. This is the given circuit. Then what is the second step? You can eliminate the voltage source. How to eliminate voltage source? That voltage source is simply deleted by considering short circuit. Then taken as SC here. Okay. Then simply understand here after deleting voltage source, the circuit becomes three loops. Okay. I1, I2, I3. Then simply you can find out all the currents by applying KVL for each loop. Then apply mesh analysis. Nothing but apply KVL to first loop, that is loop 1, where I1 is passing here. Okay. Then write down equations here. Write down equations in terms of impedances. Okay. Then the current passing I1 is through 8 J10 minus J2. Then simply 8 plus J10 minus J2 into I1. And also J10 is mutual element. Then I3 is also passing, but J3 is in reverse direction. Then taken as minus J10 into I3. For minus J2 also mutual element, I2 current is also passing. That's why minus of minus plus. Then J2 into I2. There is no voltage source in the circuit, then equal to 0. That is the mesh analysis. The total voltage drops across each element is equal to 0. Then simplify that equation, you will get here 8 plus J8 into I1 plus J2 into I2 minus J10 into I3 equal to 0. This is the first loop equation. Similarly, we can consider second loop equation. Okay, na? What is second loop equation? Then simply apply KVL to second loop. Apply KVL to loop 2. Similarly, in the loop 2, observe the circuit here. In the loop 2 also, I2 is current passing through the three elements. Okay, na? That is 4 minus J2 minus J2. The three elements are having current passing through is I2, but minus J2 and minus J2 are mutual elements. That's why both are reverse direction. Then minus of minus plus J2 I1 and other element J2 I3. Here also no voltage source, then equal to 0. Then simplify the equation here. Simply what is I1? That is J2 I1 plus 4 minus J4 I2 plus J2 I3 equal to 0. This is taken as equation 2. Then simply understand here the third loop here. What is third loop? This is the third loop. In third loop, already we have current source here. This current source 5 amperes is passing through the third loop. Then what is the meaning that here? The value of third loop current is 5 ampere source. Okay. Then simply from third loop, I3 value is 5 amperes. This is the current passing through the third loop. Then based on this I3 value, you can simplify the other equations. Okay. Therefore, that is replace I3 value in equation 2. That is from equation 2. You can replace the I3 value here. Okay. That is what happened after replacing J2 I1 plus 4 minus J4 into I2 plus in place of I3 we have 5, then 5 into 2 that is 10 becomes J10 here. Then after that we have to find out from this equation, we have to find out the value of I1 here. That is, you can find out the value of I1 in terms of I2. Then what happened here? You can divide the total equation by 2. Then the equation becomes 2 plus J2 into I2 minus 5 equal to 0. Okay, this is the I1 value here. Okay, this I1 value, you can replace I1 value in equation 1. That is, replace I1 in equation 1. Then find out I2 value here. After replacing I1 value, I3 value in equation 1, total equation becomes in terms of I2. Then simply find out I2 value after replacing I1 and I3 in equation 1. Okay. Here, then simplify the equation here. That is equation 1. 8 plus J8 into I1. What is the I1 value? 2 plus J2 into I2 minus 5. Then other equations minus J50 after replacing I3. Then plus J2 into I2 equal to 0. Then you can equating on both sides, simplifying. Then you will get the I2 value is 90 minus J40 by 34. Then simplifying here, 2.647 minus J 1.176 amperes. Okay, this is the I2 value. Then what is our aim here in the circuit? You can find out current passing through the 4 ohms branch, that is I0, and also I2 also passing in second loop, but both are reverse direction. I2 and I1, I0 both are reverse direction. Okay, this is the second case consider. That's why you can consider the current, final current is I0 double dash. Okay, then the direction of I0 double dash will be reverse. Okay, therefore, according to direction, our finding value I0 double dash equal to minus I2. Both are reverse direction. Then from that, what is I0 value here? Minus 2.647 plus 1.176 amperes. Okay, this is the second case current. Therefore, by applying superposition theorem, what is it here? The response in the element is equal to the sum of the responses by considering only single source at a time. Then we know the value of I naught dash value and we know the value of I naught double dash value. Then both values are replacing here, that is I naught and I double dash. Then you will get the value of required current is minus 5 plus J 3.529 amperes. That is in the form of rectangular form. Suppose this value you can find out 6.12 in the polar form, that is 1.144.7 degrees. Okay, remember when we are doing the problems in impedances like RLC parameters, that is all impedances, all calculations, you must calculate both values, that is the in rectangular form as well as in complex form. Okay, in this way, you can verify the superposition theorem by considering only at a source. Single source you can take. Then find out the our required response in the given problem. Subscribe our channel and share to your friends.